Bem-vindos de volta. Como vimos antes do intervalo, a tecnologia está em constante evolução para oferecer aos nossos utilizadores ferramentas mais eficientes, que permitem resultados mais precisos e soluções para uma tomada de decisão também mais consciente.
O Reality Mapping e os Digital Twins materializam esta visão. São eles que nos permitem recriar a realidade de uma forma digital, criar modelos que nos permitam criar cenários para materializar diferentes alternativas dessa realidade e usar a informação e essa visualização e análise para poder tomar melhores decisões.
Nuno, mas para nos falar sobre isto, ninguém melhor do que um apaixonado por transformar a forma como as pessoas entendem o mundo através da tecnologia. Please welcome from Esri, Arkadiusz.
Arkadiusz?
Good morning, Portugal. My name is Arkadiusz, and I'm here to tell you why and how imagery and reality mapping is fundamental for your digital twin journey. 90% of the data ever created was created in the last 2 years. That's a research from Norwegian Sintef. And of course, majority of this data has been social media posts, videos, but mainly images. 80% of decisions we take today include the geospatial components. Spatial information has been a mainstream. Look on it from this perspective. In this room, which is a very beautiful room, there's far more devices than people. Those devices, they can take images, they collect location, they collect data. And to manage this, to extract information of it, you need to have a good system. Let's start with definition. What is reality mapping? Reality mapping is the process of creating the digital representation of the world. I was challenged by my son, who came back from school a few months ago, and he was like very not happy and said, "Daddy, why can't you be a firefighter or carpenter building homes?" Because today I had to speak in front of my class what my father is doing for a living, and all I could come with was that you are typing in the keyboard and talking on the meetings. So I explained to him that you were born with 2 eyes. God gave you 2 eyes, and think that each of the eye is a camera. You have 2 eyes with a stereo vision, with a little bit space in between them, and you have a very powerful computer, which is your brain. You are collecting images in real time. Your lights of photons reflected from all the objects come through your eyes to your brain and compute 3-dimensional world. We have 2 eyes because when we look from the same object from 2 different perspectives, we are able to determine the depth of the object. So what we are trying to do with reality mapping, we are trying to reconstruct exactly the same what nature gave us: ability to see in 3D, ability to interpret objects and take decisions immediately. Digital twins, it's a very powerful word that is driving the geospatial and GIS business today. And we all are waiting for the autonomous future. We wait for this predictive maintenance, for automatic information. But before we reach this full autonomous future, we need to build a fundamental part of it, which is descriptive reality. We need to have a good 3D or 2D models that create a fundamental part of our analysis. And the reality mapping is a cornerstone of that digital twin journey. It stands on the fundamental part of your descriptive 3D reality. If we reflect on the history of the GIS, it has been, and you are working for many, many years with the vector data, raster data, we introduced 3D objects, and now we are introducing the reality, which is not here to replace anything. It's here to give you the 3D photorealistic base map that can interact with your GIS, with your system of record, and provide you a new immersive insights. This technology can produce point clouds from images, DSM models, so digital surface models, true orthophotos, and the 3D mesh models. We have different applications for that. There are standalone or SaaS applications or desktop applications. This we can discuss further on the technical sessions. And what is unique about it with Esri is that we are able to create it into the end-to-end solution, into the seamless experience for the user that can go all the way from any type of imagery through our pre-processing tools all the way to the client applications, extraction of the insight, analysis, dashboards. I like to position this that reality mapping is feeding the GIS with the new content. It's allowing the user to operate with either the drone, aerial, or satellite imagery, process this data, and ingest it into your system of records, system of insight, system of engagement. The first stop and the source of all the reality mapping is usually the oriented image. Image has a location and orientation. Oriented image is a very powerful tool because we know the location of the image and we also know where we are looking at. So if we connect the oriented image with the 2D or 3D GIS, we are able to do the asset inspection, asset inventory. The second very important product is a DSM and true orthophoto. The difference is very important to understand. The true orthophoto is rectified on the digital surface model. So we are correcting for any leaning of the objects. We are eliminating all the occlusions. Occlusions are the part of the images that are not visible because of the building has been leaning. So when you produce the traditional orthophoto, you will have that kind of effect. Think of the future with the GOI, where automatic extraction of all the objects will be commodity. You need to have a true orthophoto as an input. And the last product and the most advanced is this 3D reality mesh. This is where we try to reproduce what our eyes and brain is doing, where we convert this point cloud into the network of the triangles, texture this with the colors, and create this beautiful, but also accurate and very useful 3D meshes. We operate at any scale. Reality mapping, and we are hardware agnostic. Reality mapping can consume and ingest satellite imagery. We are able to work with Airbus, Pleiades, Maxar imagery, Black Sky imagery. We are able to operate with any camera, aerial camera sensor. Or also we are able to use the drone imagery. Different altitude, different resolution, different scale, different accuracy. To prove that we operate at any scale, we also conducted a test with the nano drone. That is operator. That kind of nano drones are used by the military that you've seen in the presentations earlier today, how important it is to have a situation awareness. So again, the quality of the reality mapping depends on the resolution, also overlap. We can go to sub-centimeter. It all depends from what is your need and what are your sensors, what kind of accuracy you would like to achieve. Those are examples from aerial imagery, where from 2.5 centimeter you can clearly see all the objects. You can see this yellow post box in Germany, but on the 10 centimeter it starts to be melting, and the small object like post boxes might not be identifiable. So you need to choose your resolution to your purpose and your insight. Reality mapping is going across all the sectors at Esri. So we are a cross-sector, we are cutting through any silo, and we are willing to support any part of your work today. Because it's a new 3D immersive base map that can be used in the combination with point features, with line analysis, line of sight analysis, urban planning, spatial analysis, or even real-time feeds and IoT sensors. And it all looks nice, but you might ask, okay, what I can actually do with it? On the next few slides, I will show you multiple examples from our customers, how they put it at work. From plan and design, analyze, simulate, inspect, and operate and maintain. How reality mapping is a stakeholder and an important contributor to your GIS work. The first example comes from the city of Oslo, where reality has been a very important stakeholder for urban planning. City of Oslo replaced the traditional object-based model with the reality model and is communicating to all the citizens how they will be developing the city. All the parcels and all the investments are published through the story maps with embedded web scene layer, where reality represents the city and the new architecture models are being published. Those can be combined with the street-level imagery, so the user is able also not only to see from the urban position, but also from the street level. What you will see in the moment, you are seeing on the left-hand side a reality model with the urban planning designs, and on the right-hand side an oriented image from a street level. Another example, which is a spatial analysis, a heat map of the traffic accidents in the city of Munich. So traditional heat map plotted into the 3D mesh model. It creates a completely new context for your content. You might discover patterns that were not visible in your 2D view. Solar analysis, solar power. We are all going towards the sustainable and renewable energy. Using the DSM models and true orthophoto and the reality mesh models, we are able not only to calculate the potential of the solar potential, but also communicate and visualize this to all the property owners. Spatial analysis and location allocation. So using the reality mesh models as a background to visualize the relationship between the points of interest and any other location allocation attributes. Back to Oslo, where the urban planning department was faced with a lot of the concerns regarding the city development plans and building the skyscrapers. They used the 3D mesh model because it is watertight model as a subject of the analysis to analyze airflow distribution, noise distribution, soil, and the shadow distribution in the city, and communicated it to all their citizens. With ArcGIS Pro 3.3, the simulation of the water flow has been introduced. So we are able to, right now, with a 3D, simulate how the potentially flood or any other accidents with the water will act. So using the three-dimensional model, we are able to simulate the water flow on the scale, but also using the very photorealistic 3D mesh models, we could simulate what will happen if there will be a huge, for example, flood wave coming through the city. It's also possible to interact this with the 2D map about the absorption of the water, so we are able to determine which parts of the ground will absorb water differently. Another example from utilities, where 3D mesh model is used as a situation awareness, a background model, an oriented image for asset inspection. Everything connected with the GIS database, so user is able to rotate, find objects of interest, inspect them with oriented image, connect with the database, annotate, and synchronize with his system of records. Utilities are also underground. In Poland, OPGK company is transforming a 2D, very complex analog maps for the utilities into the 3D world. And look on this, how much more immersive and how much more context we are getting by combining the three-dimensional utilities information with reality model. How many accidents could be avoided if the contractor or operator in the field have that kind of insight and information. More practical example, mining, where using two different reality mesh models, we are able to digitize or detect the changes of this, for example, pile of the material, and use it for volume calculations and visualize and document the change detection. Image can be also in motion. So drones can collect images, but also video. And thermal inspections of the solar panels is a very important aspect of the inspection, because with the natural colors, we are not able to see that the panel is overheating. Here, user is looking on the three-dimensional model that provides him situation awareness, and the thermal video provides him an asset inspection view, and he's able to annotate by combination of the reality mapping mesh model and thermal information. Real-time feeds. So I mentioned these devices. We are living in the connected world, interconnected world, where the devices collect location, they can provide the velocity information, and we are able to use the reality mesh model as a background to visualize all these IoT and real-time feeds in a very immersive and user-friendly way. The Department of Transportation in the city of Utrecht has plotted all the road signs on top of the reality mesh model to perform the asset inventory, asset inspection. So now the road signs are visible. You can see them in the context of all the surrounding reality. And this is connected to their system of record, and they can perform the asset inventory. And one of the last examples, we are now in the very comprehensive model where we were in the city of Denver, where the mesh model has been produced for entire city and connected with all the 3D GIS information. You will see in a moment feature layers, point layers, and polygons and all the 3D GIS information. So as I mentioned, reality is here to help you see your GIS content in the very realistic context. That there is a lot of information that you do not have to describe in layers, points, or features, because the reality is giving you this very immersive contextual information. Oriented imagery can be superimposed with the photorealistic models, so we are able to see them in the same perspective and also see the changes. In a moment, you will see an oriented image and a 3D mesh model. So you can clearly see that 3D mesh model has been produced after the construction of the building, and the oriented image has been captured from the street level. So, and this is one of the last video examples where I'm showing that complete workflow for a drone data capture of the dam in the US, where the user has performed the flight, the aerial flight, also inspection flight, with an ArcGIS Pro using reality extension for ArcGIS Pro produced the true orthophoto DSM model that you are looking right now on, and then also 3D mesh model that I was mentioning on the very beginning. So we are working with the ArcGIS Pro with the extension for the reality, and then in a moment user is connecting his oriented imagery and performing the inspection of the dam. This can be done for any other asset. We are able to connect oriented imagery. We are able also to connect full motion video that we will see in a moment. And on the reality, we are able to see a footprint and live stream of the position of the drone, but also where we are looking in the video footage. So, if you are on your journey to build digital twins or adopt digital twins in your organization, I would like you to remember these 5 very important steps. That your journey should start with defining what is my reality. What accuracy I need to have it? Do I need to have it in 2D with the true orthophoto or maybe in 3D mesh? And then implement a good reality mapping. Create this descriptive model and build on that your applications. Because once you have this descriptive model, you can connect it with your existing system of records or your other GIS data. We are very welcome to use ArcGIS Living Atlas and all the content that is available then, or open data. We are very open to integrate through the various APIs. Then consider if you would like to include also real-time feeds, IoT sensors, and then start building solutions applications. This is the very good recipe and very good start point for your digital twin journey. So, my name is Arkadiusz, and I hope that I inspired you how imagery and reality mapping is the fundamental for your digital twin journey. I have 3 minutes left, so I'm happy that I have it. So I would like to do a social experiment. I have one last video, digital twin video, and I love the theme of the conference, that it's together. So let's try to do something together, and let's try to say it in Portuguese, which is juntos, right? Yes. And let's make this moment memorable and famous, so if you are okay with me. So I will play the video, and on 3, when I say 3, we all say together in Portuguese, okay? Okay, are you ready? All right, 1, 2, 3. Juntos, together, thank you very much.
Thank you.
Thank you, Arkadiusz. What a presentation. No, it's fine. Thank you.